Good morning, everybody. So the title of our production is EOR, a recommendation for the future of Louisiana's Livingston field. My name is Jason Diedjomahor.
I'm Zach Powell.
And I'm Zeno Price.
Our project is about enhanced oil recovery. The goal of our project is to do an evaluation on the Livingston field and provide a recommendation for the future of the oil field. Livingston field was discovered in 1983. Since that time, 22 successful producers and a secondary water flood in the reservoir has resulted in the cumulative production of approximately 8.8 million barrels of oil and 4.7 billion cubic feet of gas. Several previous field studies have estimated that the original oil in place was to be between 24.5 and 32.6 million barrels. This indicates that the recovery factors are low. There are opportunities for EOR techniques to be utilized.
So, procedure. For building the model, we were given the data of this model. For building purposes, we use CMG, IMX, results, and builder. As you can see to the right, this particular model has a grade of 74 by 34 by 8. We were also given a PVT data for the rock fluid properties, well location, and initial conditions. For history matching, we were given the production history of the oil rates, the water rates, cumulative liquid rates, beginning in the year of 1983, all the way up until the year of 2009. The data was priorly history matched up until 2001, and we had to go back and manually add the production history all the way up until 2009 into the simulation. From here, we were then able to forecast the base case up until the year of 2030. Next, we then drilled a new well and forecasted that well. We turned one of the wells that were shut in into an injector, and we forecasted that well as well. Then we were able to inject solvent, and this is where we were able to find the cost to drill a 10,000 foot infill well and how much it would cost to inject solvent at a specified rate. From here, we were able to calculate our economic cost.
So this is an image from results of CMG, and this is oil saturation, and this is in 2009. This is an aerial view, and you could probably see the green outline on Q, F, and U. Those are the producing wells at this time in 2009. And in the southwest corner, you can see there is a high amount of oil saturation. This is where a natural fault lies. And so there wasn't a lot of implementation in this area. Next slide. So this is our forecast, and this is base case. This is just the 3 producing wells forecasted to 2030. So this is over a 20-year span from the previous slide. You can see there was a little bit of oil production from the producers, but not as much as we would like. So, and this is cumulative production. This is forecasted to 2030, and this again is the base case. And we forecasted a cumulative production of about 9.88 million stock tank barrels. This is the same graph. This is oil saturation. And again, this is in 2009. And we decided to drill an infill well at the southwest corner where that fault lies. And we called it well 33. And so the red is the high oil saturation and the green is low. And we actually have a video of a time lapse of well 33 producing. So you can play that video. And so the time is still going. It's around 2020 right now. And so well 33 produced a lot of oil really fast, but it's not sweeping all the way, and it's not producing at high rates in the late stages of its history. It produced very high rates at first, but then it dropped off very fast. And this is a graph of cumulative production for well 33. This is just well 33. There's other producers producing at this time, but this is just cumulative production in this 20-year span for well 33. And it produced 615,000 stock tank barrels. So this is, again, oil saturation in 2009. And this is our solvent injection. And so our goal with this solvent injection was to inject solvent to push the residual oil towards the existing producers. So that would be Q and F in the middle of this image. And we changed well B, which was a producer. It was shut in 2009, but we changed it into an injector and injected solvent. And we injected solvent at a rate of 2,000 MSCF, and this is constant. We held this constant over 20 years. And we have a video of the oil saturation over time. And so you can see the injector injecting the solvent and pushing the oil towards the producers. And this is cumulative production of the solvent versus the base case. So the solvent is the dash line, and the base case is the solid line. And so we forecasted that the solvent injection increased the cumulative oil production by about 1.5 million stock tank barrels over a 20-year time span. And this was at a constant rate of 2,000 MSCF solvent injection. And this is our final results. So this is all three in one graph. So we have base case in green, we have solvent in red, and we have the new infill well 33, and these are all cumulative production. And this is oil rate, and this is throughout the entire history. And it's the same colors as the last slide: base case in green, solvent in red, and well 33 in blue. And if you look at 2009, you can see a huge spike in oil flow rate. That's well 33. So we saw extremely high flow rates in well 33 initially, and then you can see it drops off very fast, the flow rate.
Economics. So as far as economics, we're talking in order of magnitude, not exact cost. So as an example of this is this going to cost us 100,000 or 1 million or $10 million? So a conservative estimate for a cost of solvent injection would be about $9 per barrel. There was about 360,000 barrels of solvent injected over a 20-year time span. This would give us a rough estimate of the solvent injection being about $3.2 million. Total revenue from the solvent injection was about $90 million over a 20-year span. Drilling a 10,000-foot infill well would cost about $1 million. And the total revenue from the new well that we drilled would be about $37 million. In conclusion, based on the results and economic evaluation of the project, we can see that solvent injection is a very viable option that can elicit high oil production and already existing producers. For our project, we only had one injector to keep things fairly simple, but there's much more opportunity to create more solvent injectors to produce even more oil. And drilling a new well could be very much worth it in short term, but production drops off very quickly over a few years, as Zach mentioned earlier. Any questions?
Okay, please stop your share and then we'll open everything up and questions for the group.
What solvent was utilized? Was it carbon dioxide or surfactant, or just what did you use in this analysis?
It was supposed to represent surfactant flooding. We used the solvent feature in Builder, but we changed the properties of the fluid in the DAT file. And so we were trying to imitate a surfactant flood.
What is the context of the fluid in this reservoir, and why did y'all intentionally choose the surfactant?
We were given some background on this field, and there was a drilling company by the name of TMR. They were initially considering surfactant flooding. And so that's why we decided to try to make that forecast and see what a surfactant flood would look like.
Right.
Yeah, was there any consideration for drilling horizontal producers?
No, we didn't really consider horizontal in our project.
Thank you.
Looks like Steve's ready.
How did y'all develop or come up with the idea for this project? What drove you to this?
So, you can go.
Go ahead.
So actually, last semester, we kind of changed our project going into this semester, and Dr. Hughes pretty much gave us the data of some documents that we felt were interesting, and we just pretty much try to build a model based on Livingston oil field. And it's also pretty close, so that also played a huge role into this.
Yeah, we were interested in EOR, and our original idea was like we wanted to drill a well and we were gonna implement these EOR techniques, but like that wasn't a viable option. So we had to rethink our project, and we still wanted it to have something to do with EOR. So.
Sorry. And so what would be the next steps for this project to investigate?
Well, there's infinite steps left in this project. We could try, just simulating like the question earlier, horizontal wells. We could try wells, multiple wells. We could try gas flooding.
So I guess particularly there's lots of different ways to go, but for the path you guys chose, what would have been, if you had a little bit more time, what is the next thing you would have wanted to look at?
Probably just being more optimal with the way that we did things, because we chose well 33 in that location, in that grid block where the fault kind of lied. And we chose a few other locations, and we simulated those, and well 33 outproduced them by a lot. And but we didn't try gas flooding and also the constraints on the wells. We just kept them the same as the other producers, but maybe if we changed the constraints of the well, maybe it would have produced longer over time. Like it had a high flow rate at first, but then it drops off. So maybe if we change the constraint, maybe it produces for a longer time and eventually produces more.
Was there any consideration to pattern flooding? I know primarily you're looking at one injector and well 33 as a producer, but did you give any consideration to pattern flooding at all?
Yeah, we gave consideration to it. We tried to keep things as simple as possible, because if you keep them as simple as possible, you have less error. And this is a forecast. And so less error gives you more accurate results.
Okay, and one last question. Did you consider Dr. Rao's gravity assist gas injection?
So you can see that they don't have to take another class from Dr. Rao, because they didn't do the political thing, right?
You're right.
Just wanted you to know I'm still listening. I don't know if we are supposed to ask questions, Richard, but
well, so let's let them answer Ray's question first, and then get yours. You got plenty of time.
Well,
did you consider GAG-D?
No, I just heard about that last semester in Dr. Rao's class. So, I'm not very well educated on it, but I could have looked into it, yeah.
Okay, Dan, your question.
well, in the surfactant flooding, there are wettability effects involved due to chemical interactions. So, and they alter the relative permeabilities. And did your modeling take into account your reservoir simulation? Did you alter the relative permeability effects caused by the surfactant?
I don't know if we changed relative permeability. I know we tried to change a lot of fluid properties in the text file so that we could simulate a surfactant, but I'm not sure if we changed relative permeability. Zeno, do you know if we changed relative permeability?
No, we didn't. We left all of like the constraints and everything the same.
Thank you.
Why did y'all choose the injector location for well 33? Did you consider other wells to convert to an injector?
Yeah, we actually did. There was 2 other wells that were close to, I think it was F and U that are producing. I would have to look at it. So yeah, there's P and X. They're injectors that are on the left and right. These are a little bit further than B was. And so, yeah, we just decided to do B, but we did try X. And we also tried water flood just for the fun of it. And it worked fine, but not as good as a surfactant flood did.
We also considered productive capacity in the selection of our choice for the location.
Okay, we're at time. I've got a few more things for the board members, and actually Dr. Rao, if you'll stick around too, that'd be good. But thank you for your presentation. We'll get the comments back to you as quick as we can.
Thank you.
Thank you.
Oh, by the way, before you guys leave, you do know that Mr. Lafang is TMR Energy, right?
Oh, really?
Yeah. So just to, you know, that's why he was prompted a couple times. But
I saw him. I noticed him smiling during the presentation.
okay.
Oh, I hope that's good smiles.
Good work,
All right.
guys.
Thank you for your efforts.
Thank
Now
you.
we're going.